Okay, so this section of the chapter refers to, as you guys explored a little bit yesterday in your activities, it explores the comparison of a population and a sample. So just as a reminder, a population is an entire group of people, and a sample is just going to be part of that. So as a reminder of what you did yesterday in your activities, you had to identify a population and a sample for each one of these situations. So population, sample. Now in part A, the population would be the whole school. So the population is this guy, it's the students in the school. The sample of that would just be a small subset, which would be the students in the math class. So the population is the big one, the sample is the small one. Now in part B, you see there are two choices. There are grizzly bears with GPS collars in a park, and there are grizzly bears in a park. So the population is going to be all of the bears in the park. So this one is your population, and the sample is just the small subset that have the GPS collars. So just a quick little review on population and sample. Now the idea, I'm going to go back to this one, the idea of using a sample out of an entire population is you can use that sample to make an inference or a conclusion about a population. So if you wanted to get a feel for where grizzlies are in your park, it doesn't really make sense to survey all of the grizzly bears or to keep track of all of the grizzly bears. So what you do is you take a small sample of them, and if you choose that sample appropriately, then it should be representative of what's happening in your whole population. So in order for us to make an inference of the sample that is supposed to tell us something about the entire population, it's going to be beneficial for us to have a random sample. So this is the activity from yesterday, and for this one you're to determine if each method will result in a random sample. So if you're going to survey people at your school, if you were to ask members of the school band, that's not necessarily a random sample because members of the school band all come from the same group and might have similar views about something. So if they're trying to figure out their extracurricular activity, if they're in the school band, then most of them might be more likely to say that their favorite extracurricular activity is band. So this one would not be random. Not a good random sample, which would be representative of the entire population. Publish a survey in the school newspaper. That's better because you get a wider variety of kids that read the school newspaper. So I'd say that'd be more likely. More likely to result in a random sample. You ask every 8th grade student who enters school in the morning what their extracurricular activity is. Even though it's more random than asking people in the school band, it's still not quite random. There might be different interests. Because they're all in the same grade level, they might have similar interests. And then asking students in your class, well, that might be better because everybody in your class comes from a different background. They might still be in the same grade level, so it'll be more of a random sample. But the reason we want to determine a random sample is because sometimes, depending on the type of sample that you survey, it could result in a biased sample or an unbiased sample. And what you want, what you're going for, is an unbiased sample is really what you want. It's going to be representative of the entire population, and its goal is going to be it's selected at random and it's large enough to provide accurate data. Now, a biased sample is going to have, it's not going to be representative of the entire population. That would be the case of surveying, in this case, asking members in your school band. That might be biased because they might be biased to say that their favorite extracurricular activity is the band. So a biased sample is where one or more parts of the population are favored over others. So on to the examples for this lesson. First, we're going to identify an unbiased sample. So we have multiple choices here, A, B, C, or D. We want to estimate the number of students in a high school who ride the school bus. So if we wanted to get an idea of how many students in the entire high school rode the school bus, which group of students would we want to ask to represent that population? So our choices are 4 students in the hallway. So even though you're coming across random students in the hallway, it's random, but it's not large enough. So 4 students is too small. Now if we asked all students in the marching band, they might be different grade levels, but it could potentially be biased because they all come from the same group. So that one's out. Now if we were to ask 50 seniors at random, so 50 is a big enough sample, so that would be okay. But the fact that we're asking all seniors, think about the types of answers they might give. Those are older students, they might be less likely to ride the bus, so that might give us a biased sample. You might get a lot more people in that case saying no, they don't ride the bus, so that one's also could potentially have bias. Now, if you ask 100 students at random, at lunch, you get a big enough sample, and everyone eats lunch, no matter what grade level you're in or what your outside interests are. So in this case, D is going to be our unbiased sample. Going to example number 2. Using the sample to determine whether conclusions are valid. You want to know how the residents in your town feel about adding a new stop sign. We have 2 parts to this question coming up, and so we are going to determine whether each conclusion is valid. So if you wanted to get an idea of how the residents in our town feel about adding a stop sign, well, if we were to survey 20 residents who live close to the stop sign, and you find out that 15 support the sign and 5 do not, so you conclude that 75% of the residents in your town support the stop sign, think about where the residents that you asked, if they live near the stop sign, they might be more likely to support the stop sign. And so in that case, these results could be argued as invalid because they might be more likely to support the stop sign if they live near it. Now, if you were to take the same proposal, trying to identify how many of your residents support the stop sign, if you survey 100 residents, that's a bigger sample, so it's better, and if it's just at random, and you come to these conclusions, you conclude 40 support the new sign and 60 do not of the 100 that you sampled, you could conclude that 40% of the residents support the new stop sign. Because it's a big enough sample, and because it was more random than the previous one, I would say that these results are in fact valid. Now we can use making predictions. So using populations and samples to make predictions about things. So let's say you have, I'll go back to the highlighter for this. So let's say you have, you ask 75 random students how many movies they watch each week, and here are your results. So out of 75 students, 21 of those students watch 1 movie per week, 30 of those students watch 0 movies per week, and 24 of those students watch 2 or more movies per week. We can use that to tell us how many we would expect to watch 1 movie per week out of 1,200 students in the school. So, out of a total of 75 students who were asked, now we're looking to compare this idea of watching 1 movie per week. So as it turns out, 21 out of the 75 that were surveyed watched 1 movie per week. And we can use that fact to figure out how many students would watch 1 movie per week, not out of 75, but out of 1,200. And so we wouldn't want to figure out how many out of that 1,200 watch 1 movie per week. And so now we can solve this proportion. I would first, before solving this, I would simplify this guy. So I notice that I can divide both of these by 3 at least. So 21 divided by 3 is 7, and 75 divided by 3 is 25. And it equals x over 1200. Make this bigger. And now we can cross multiply. We can go 25 times x is 25x. And then we can go 7 times 1200. Pull my calculator. 7 times 1200 is 8400. And then to get x by itself, I'm going to divide both sides by 25. And I would get, so I'm going to pull my calculator again for 8400 divided by 25. And I am left with 336 students out of the 1200 that were surveyed. We would expect to watch 1 movie per week. So there you go. Hopefully that was helpful. Good luck on your Big Ideas Online assignment. Refer back to this video as needed.